Hello, everyone. Welcome to IPS 450 Software Assurance. So today we have a lecture today, and then as you know, on Thursday you will just continue with your lab assignments. So basically, Thursday will be the last day to work on that lab. So actually, I have let me switch over to Brightspace so I can show you the schedule. All right, so I've updated the calendar at this point. I wanted to look at the rest of the semester. So you should be seeing Brightspace right now, and then I'm gonna go to the so where is the give me a sec, guys. This did not work out. Huh. It's so difficult sometimes to navigate this Zoom thing. All right, so this is where I want to go. So I'm going to share the calendar. All right. So you should be seeing the calendar now. And as you can see, I've updated. So we are currently here. Last week we had our project demos. I already posted the grades for that. And then here, this is where we are today. So as you know, today we are going to go over the box testing model, which is something that you will need for your term project. So I will discuss that. I also have another topic that I kind of needed to cover at some point in the semester. So I'm just going to throw it in here. And then the rest of the class will just be finishing up the discussion of SQL injection. And then as you know, you will have Thursday to work on the SQL injection lab. This lab is going to be due a week from the 29th, so it'll be due on November 5th. Next week, November 3rd, we will begin our discussion of JavaScript injections. So now, just like we did SQL injections here, now we're going to have JavaScript injections. And in particular, we're going to look at a lab called the cross-site scripting lab. Then after that, November 10th, we will have our second written exam, just like we did with the first exam. And then you'll have on the November 12th to finish up the cross-site scripting lab. Then after that, we're going to do the cross-site request forgery topic, which is another type of JavaScript injection. And then after that, as you can see, I'll have a few miscellaneous topics. And then finally, our presentations will be December 8th to the 10th. Remember, you need to work on that project. I can't stress enough how much, you've done the demos already. I might do yet another demo sometime around here on November 19th. Okay, just to make sure that you're addressing all the things that need to be addressed. So keep in mind, today I'm going to talk about the issue with software testing, and that's a big component of the project. Okay, so I'm going to talk about that one. All right, so anyway, so if you want to take a look at the calendar, that's where it stands. And then, of course, our final exam during finals week. All right, so anyway, I wanted to mention that. Are there any questions about the calendar?
Nope.
All right, great. All right, so now let's go ahead and switch over to the slides. So I have some slides for today. So, today we have several topics actually. So as you know, sometimes in the semester, I end up with some little miscellaneous topics that I need to cover somewhere, or other. And, today was like a perfect day to squeeze in one of these topics. So today really, as I said, I'm going to talk about the box model of software testing. That's in these slides. Plus, I'll provide an example of how to do that for the project. We'll talk about the box model of software testing. Okay. Additionally, I'll touch on some final topics of the SQL injection lab. And then that way you can focus on the SQL injection lab, or if you have any questions on Thursday about them. And then finally, I'm going to introduce, I'm actually going to start with this topic today, which is called integer security. So it basically has to do with checking numbers or types. Or ranges. Now this applies to both, to languages, low-level languages. This applies to low-level languages like C, C++. Okay, but it also applies to high-level languages like JavaScript. Like JavaScript and PHP. And for that matter, SQL and all of that. Right, so this is one topic that you will. It's very straightforward, really, for high-level languages. It's very straightforward. You just have to check in your input boxes, validate, basically input validation, right? And in the project you have a lot of in the project you have a lot of JavaScript based input validation in there, right? So you have that already where you're checking ranges, right? And you just want to make sure that if you're reading in a temperature, okay, you're not going to read in like 10,000, right? So that's not a temperature that you would experience, or values, meet, zip codes, for instance, are numbers, so they fall, they fall within a specific format, etc. So it's pretty easy in JavaScript, and that's kind of what it's gonna, that's why this is a good place actually to cover the box model of testing. So I'll talk a little bit about that, and that, those are the approaches that you will take in the term project just to test your software. And so I'll provide some formal definitions of this. Now, when you talk about integer security for a low-level language like C, C++, that has a little bit more of an implication. Okay, that has in C, C++, low-level languages, the unexpected behavior with integer numbers or with numbering in general can have, more serious problems, okay? And so we will explore that today. So today it's a little bit of a, talking about both in C and in, or low-level and high-level languages, I should say, low-level and high-level, and it'll just help us to better understand these ideas. Okay, so let's continue. All right, so anyway, so that's what we're going to talk about today. So integer security will not, as far as for C, C++, integer security, as far as for C, C++, will not have a lab, okay? So I don't have a lab for integer security this semester. Instead, for the high-level languages, obviously, you're just gonna, when you do the testing, you're gonna check for that. And I'll show you today the testing template that I want you to use. The testing template, okay? But as far as for CC++, we still want to address it. You know, questions about this could appear on the exam, and you know, but really, you know, we're just going to discuss it today in the lecture. If you have any questions, let me know. But it should be interesting. There's some interesting ideas in there. Okay, so that's the plan for today. So a little bit of a miscellaneous today, miscellaneous topics. But you know, just I have to do this every now and then, and today just works perfect for that. All right, so let's, and please, if you have any questions at any time, just stop me. All right, so we can address them. All right, so let's go ahead and start. All right, so as you know, so remember, everything that I'm gonna cover for the next 15 slides or so, it's gonna relate to CC++. So it kind of goes back, put on your buffer overflow, you know, format string type of a helmet, right? And try to remember those topics, you know, that, because that's really in the realm that I'll be talking for the next few slides. All right, so integers. So you've used integers, obviously, in CC++, you create variables, and you know that whereas in high-level languages like Python, JavaScript, you really don't declare variables that, you know, that much or into too much detail. Here in CC++, it's the total opposite, right? You have so much, so many decisions to make when declaring a variable, right? You have a lot of decisions to make when you're declaring a variable, and because you have so many data types. And the reason why we have so many data types in CC++ is really that that you really want to, you know, C is about efficiency and memory management, space in the hard drive, etc. So there's a difference between, you know, one variable or the other based on the data type, and that determines the amount of space that's taken up, right? And that amount of space is quite important for efficiency's sake. Right, so integers then, because of this, represent a growing and underestimated source of vulnerabilities in C and C++ programs, and in other high-level languages as well. So integer range checking, right, has not been systematically applied in the development of most C, C++ software. Okay, and therefore security flaws involving integers can exist, and I'll show you a few of them. Most of these, again, remember, software assurance is both about quality and security, or reliability and security, and most of these will be reliability, but some of these could result in security issues. So a portion of these, in fact, are likely to be vulnerabilities. Excuse me. A software vulnerability may result when a program evaluates an integer to an unexpected behavior. And remember, that's really the key word in a lot of this. You didn't expect it, so it's unexpected behavior. Signed, so as you know, in integers, in C, you have signed and unsigned types of data. Integers in C and C++ are either signed or unsigned. For each signed type, there is an equivalent unsigned type. Integer representations vary in how they represent negative numbers. That's why they're called signed and unsigned. So here's an example. So the signed magnitude representation, so it uses the high order bit, this one and that one. So it uses the high order bit to indicate the sign, whether it's 0 positive or 1 negative. So in the remaining low order bits, that is these and these, indicate the magnitude of the value. So here, for instance, you can see we have 6 values, 2, 4, that's 6. So that these values represent the number. So you can see they're both the same. In binary, they both represent 41. And, oh, not 42. 41. And then the last one represents the bit that indicates whether it's plus or minus. So you can see here the sign magnitude representation of plus 41 or minus 41. Okay, so that's the issue there, that you have more power, but this can result in problems. So signed integers are used to represent positive and negative values. But something might be 8-bit, but because you've lost that top bit, now it's really technically only 7-bit, so it can only represent ranges of numbers that are 7-bit, not 8-bit, because of the sign. And so that, if you're not aware of that, and if you're not careful, that can cause a problem for you. So there are standard types. Standard integers include the following. So look at all the options. You have short int, you have int, long int, long int, right? And all of these have to do with the fact that they're a little bit bigger than the other one. Okay, and so that's really the idea here. All right. So here's I really like this graph. I think it's such a good graph. And so here you can see what we're talking about in these slides. So you have signed char or unsigned char, or you have short or unsigned short, right? So one is signed, so that means numbers can be positive or negative. One is unsigned, so only positive numbers are represented. So what happens is this can only represent 255, right? 256 individual things. And so when you do sign, because you're taking that last bit away for the minus or the plus, then what that means is you really cannot represent 256 anymore. You can only represent from 0 to 127, except that it can be positive or negative. So really, in essence, you end up representing from minus 128 to plus 127. Do you see that? And if you think about it, that same range, it kind of shifts over here when it's unsigned, because you no longer represent the negative ones, right? You only represent the positive. So then you have all 8 bits again, and that gives you 0 to 255. And so that's really the problem. And this over here, this is just another example, but with larger numbers, but it's the exact same idea. Okay, and so this is how C++ works, right? So this is basically how it works. And the point of these slides from the point of view of software assurance is that this can result in reliability problems, because you may forget, you may use a signed char and you really wanted to use an unsigned char. So the question is, this one can represent 200, but this one cannot. So what's going to happen there? You see that, guys? So, let's say you didn't plan this well. You thought this was going to store 200. Turns out it doesn't. And really what happens is these kind of like roll over. So that 200 is going to end up being the difference here, which is, let's say, like 73. So this might end up being then, 128 minus 73. And wherever that hits, that's going to be the value that it gets represented. So you wanted a positive 200, you ended up with a negative number. And that may not be a vulnerability, a security, but it can certainly, cause your program to behave unexpectedly. And it might be very difficult for you to find the error until you figure out, oh, it's a data type issue. Okay? Are there any questions so far? Is this making sense?
I don't have any questions right now.
Okay. So it sounds like it's making sense. All right, so let's go ahead then move on to the next slide. Okay, so integer conversions is another issue in CC++. Okay, so type conversions occur explicitly in CC++ as the result of a cast or implicitly as required by an operation. So it basically means that data gets promoted from some data type to another type automatically, either by casting it directly or by implicitly when you're doing an operation. It might be that you're just doing, some operation, and these numbers have different data types, but they're all a type of number, and they might get promoted to other numbers. The value is still the same, just the data type has changed. So these conversions can lead to lost or misinterpreted data. So it's the same thing, right? It results in just unexpected behavior and so on. Implicit conversions are a consequence of the C language's ability to perform operations on mixed data types. Very important. And the rules of the compilers define how the compilers can handle these conversions. And so we end up with things like integer promotions, integer conversion rank of the dimensions, and usual arithmetic conversions. Okay, so we're going to look at some examples of this. All right, so integer promotions, integer types, so there's basically some rules of how C handles this. So integer types smaller than int are promoted when an operation is performed on them. Okay, so the integer types smaller than int are promoted, but only when an operation occurs, like you're adding or something, and so they'll be promoted. If all values of the original type can be represented as an int, so that's kind of like the default, and that's gonna be performed by the CPU in memory, and then the value, and then the value of the smaller type is converted to int, which shouldn't be a problem, right? So if you have a smaller data type, it's like putting zeros in front of it, right? You just convert it to a bigger data type if you have mixed types, and that way it just takes care of the entire conversion. So no problem there. However, it's good for the C programmer to be aware of that to avoid, making mistakes. That can happen. So an example of an integer promotion is, for instance, we have in integer promotions, we require the promotion of each variable C1 and C2, okay, to int. So these are char C1, C2, all right? We're gonna do the operation, the compiler will promote them, so the two ints are then added, and the sum, because C1 is char, will be truncated to fit into the char type. You see that? Integer promotions avoid arithmetic errors from the overflow of intermediate values, right? So that's kind of the goal of this process, okay? So here we have an example of this. So we have three values, C1, C2, they are, char type, let's say. And so we can see here the value of C1 is added to C2, to the value of C2. So that's 190. The sum of C1 and C2 exceeds the maximum size of a signed char, right? So a signed char, right, might be the result. Okay, and a char obviously would exceed that because a signed char goes from negative, remember? So it goes from minus to plus, whereas the char goes from 0 to plus. So it would exceed the value, okay? So if I go back So over here, we had the example, right? Remember that signed chart went from minus 128 to 127. Unsigned chart went from 0 to 255. So we got a little bit of a problem there. Okay, so the signed chart then would exceed, because it would be 190, which is greater than 127. Oops. 127. All right, so therefore the value of C1 is added to the value of C2. The sum of C1 and C2 exceeds the maximum size of a signed chart, which is 127. However, C1 and C2 and C3 are each converted to integers, and the overall expression is successfully evaluated. Okay, so that's the trick. So in this case, because we end up with 190, but then minus 120, that's, no, that's not 60, that's 70, right? 70, and 70 fits within that range of minus 127 and 127. So again, it fits within the data. So the value of C1 is added to the value of C2. Keep writing wherever this is going to appear. And then the sum, because the value is 70, the sum is truncated and stored in C result without any loss of data. No problem there. The problem would be if you did this and the resulting value was still above 127. You see the difference? So that's where you have to be careful when you're using these data types, because if you were using this data type and the resulting value was greater than that 127, even though these are promoted to integer, when you assigned it to C result, it would still get truncated. And then it wouldn't error out, or it wouldn't create a security flaw, but it would, as I said, be a reliability issue and result, and just wouldn't give you the value that you were looking for. Okay? Make sense?
Yeah.
Okay, great. So on-site integer conversions then. So here kind of like the rules in C++, conversions of smaller unsigned integer types to larger unsigned integer types is always safe, so no problem. When a larger unsigned integer is converted to a smaller unsigned integer type, the larger value may be truncated, and that's where it results in, as it was said before, loss of data. Okay, so you just, again, this doesn't require a lab. This is just kind of pretty straightforward, but it's important to be aware that even in numbers and variables, there are issues to think about as you deal, as you're trying to secure your or provide assurance for your code. Okay. All right. So now we've talked about that, and we've covered that topic. Now let's look at another one, which is called negative indices. All right. So let's take a few minutes. Please read through this code and let me know what you think is the vulnerability. So remember, as I said, when you're dealing with ranges and values, you got to think of everything, right? Now, this is not a very complex piece of code, and it's not, the error is very easy to fix. As I've said many times, when you do input validation, it's, think about how difficult it is to create a buffer overflow attack, and then think about how easy it is to prevent it, right? And it's kind of the same here. This is preventing an error here is easy, but this code definitely has a vulnerability or an issue with numbers. So take a look at this code for a little while, and please let me know what you think is the problem here, or could be the problem with this one. So you're assigning, so keep in mind, it's like an array, right? You're trying to assign value, which is passed over here, to this pointer to basically some space in memory. Remember, you're using malloc, so that means you're allocating dynamic space in memory of size int, because the value is in by 100. So that means that you have 100 int spaces in memory that you've allocated. And notice over here, you're checking that the range falls within, 100, right? From 0 to 99. So if you look at this code though, you've allocated in memory, right, 100 spaces where you're going to write a value. So it's technically like you have a buffer from 0 to 99. Oops. You have a value, let's say the value is 7, whatever. And then you pass also the index, so that means position is 15. So let's say 15 is about there. So then, you write 7 there. So what's the problem with this integer type of validation? Is there a problem, first of all? What do you guys think?
Does it have a problem with not checking for, like, you could enter a negative number, right?
Ah, very good. Why do you say that? A negative number. Well, look at position, right? What's the data type there?
It's just an int, but like the default int allows negative numbers.
Perfect. Very good answer. Exactly. So this allows both negative and positive numbers. Exactly right. But when we do the range checking, we're only checking for positive. So really, if somebody enters, -3, it'll accept it as a variable, but then that's not what you've allocated in memory. Exactly right. Do you guys see that?
Yeah.
How do you fix it? Just check for negative numbers, right? That's all you have to do. So as you can see, the solution is simple input validation, but this error is more common than you might imagine. Okay? Good answer. Does that make sense, guys?
Yeah.
Great. So I think that made sense. All right, so very good. And you can see that then, all the instructions are there. So there's a vulnerability resulting from incorrect range checking of pause, which stands for position. Because pause is declared as a signed integer, both positive and negative values can be passed to the function. An out of range positive value would be caught, but a negative would not. And a lot of the things that you will be doing in your testing for your project will be similar to that. Not the same language, but you will be checking for those types of values. As you know, in the context of your e-commerce site. So for instance, should somebody be able to purchase, 1 million books or whatever it is, you're going to have to set those limits. And you do that in the JavaScript itself. So how do you mitigate these? How do you mitigate these? Okay, so there are a lot of ways. A simple if statement. However, as it turns out, this has this mitigation, which is called type range checking, has been addressed by some programming languages, actually. So type range checking can eliminate integer vulnerabilities. There are languages out there, Pascal and Ada. I actually learned to program in Pascal. It was my first programming language. And I don't know if you've ever heard of Ada, but Ada is a language that was created, I think, in the 90s, around the 90s. And Ada is named after Ada Lovelace, who was the first programmer. I mean, I think she programmed before computers actually were electronic. They were like mechanical. And so this program was designed to be to provide structure for software assurance. Okay. So it was meant to be a very secure programming language. as it turns out, I think it was the Department of Defense or the aerospace industry that wanted this language developed because they wanted very secure software for, you know, for critical systems like an airplane, right? You can't have an airplane flying and then it's going to have a little integer error and then, you know, the thing is going to crash. So that's a very serious thing. And so these languages allow, like Ada, for instance, allow range restrictions to be applied to any scalar type to form subtypes. So that is to say, not only do you have an integer, but you actually create your own integers. Like you would say, okay, I'm going to create my integer as new integer with the following restrictions. So you can see an example of that here. Ada allows range restrictions to be declared on derived types using the range keyword. Okay, so you can see the example is in the syntax of Ada, you do type and then day, right? So you're going to say, I'm going to declare. So now this is a data type so that when you declare other variables, they get declared with the type day. So you're going to see, you're going to say type day is new. Type day is new integer. Right, as you can see there. And you can see it, it's built in the, you can see it is built in there. It is built in there that you do the range checking. So in this case, the range would be, it only accepts values between 1, ... and 31. Okay? Okay. And so that's, you know, that's a way to do it. So range restrictions are enforced by the language runtime. C and C++ are not nearly as good at enforcing this, but you can do it too. You can create objects, obviously, classes and types of, you know, like an object orient and a, okay. So you can create classes, objects, etc. All right, and then now if we want to, let's take a look at this other example here. So type range checking example. So you can see that we have a, you know, we have a program that takes something from the terminal. Right, we have a buffer of size 10. And then here we can read in the value, convert it to integer to establish the length that we want, okay? And then we just have to do, you know, some if statements, right? So we have some if statements to check that the values are in fact what they should be. So length is somewhere between 0 and buffer size, right? And so before we do the mem copy, you know, we actually change the ranges. So that's, you know, pretty much what it is. So range checking example. Okay. All right. So another example here is this is another way of declaring what I had said before, declaring data types. So you can declare an integer to store the temperature of water using the Fahrenheit scale. So you would say something like unsigned char water temperature, where water temperature is unsigned 8-bit value in the range of 1 to 255. That is sufficient to represent liquid water temperatures with ranges from 32 degrees Fahrenheit to 212 degrees, which is the boiling point. But it would allow invalid values like 131 and, you know, and above 213, right? So the best way to approach these in other languages, as I said, is, create data structures that kind of look at these ranges and do not allow them. Okay, so one solution, as you can see, is to create what are called abstract data types, right? And you can easily do that with object-oriented programming. You can create your object, and the private variables inside the object can have restrictions. So one solution is to create an abstract data type in which water temperature is private, right, and cannot be directly accessed by the user. I'm sure you've done this before. When you took an object-oriented programming class, I'm sure you went over these ideas. So that's the same thing here. A user of this data abstraction can only access, update, or operate on this value through public methods. And the public methods will actually provide the restrictions, okay? The if statements. These methods must provide type safe by ensuring that the value of the water temperature does not leave the valid range. If implemented properly, there is no possibility of an integer type range error occurring. Now you could do this so the way that you can think about this is you could do this for your term project, right? You could say, I'm gonna create a data type, a class, an object that is for money entered, right? Or it's gonna be for, some specific value that you have in your e-commerce site. And so you create the object, let's just say money. And when people are entering amounts of money, it'll check everything to make sure that it doesn't go above a certain threshold, doesn't go below. So maybe you don't allow any purchases below $2, for instance. So you can have a type of a range within that. Also, because of your business, for whatever reason, you do not want any purchase to go above, let's say, $10,000 on specific products, because those products would go from being just supplies to becoming capital assets, like a car that needs depreciation and things like that. And so a lot of that can be worked in with these abstract data types, just to provide more validation for your problems. Do you see that, guys? So it's just, just ways of creating more restrictions to prevent errors. So you have class, price, or cost, and then within it you have a private method, let's say cost, right, initialized to 0, but then you have a method over here, a function, and the function, when it takes in to initialize cost, initialize init cost, it takes a value. Before it assigns it to cost, before it assigns val to cost, it's going to do a series of if statements, right? And that's really the trick. So the if statements are going to depend based on your logic. So you do range checking, data type checking, which probably already happened in the JavaScript too, but also more logical things, like what I said about the data abstraction. And that's what happens here. Okay? Any questions?
Nope.
Okay. All right, so let's keep going then. As you can see, it's pretty simple. I mean, there's not much here. Also, the compiler, as you have seen, GCC, G++, they do provide some limited support for detecting integer exceptions at runtime. So they'll do some range checking, but you really should be responsible for all of that yourself. And in particular for the term project, you'll have to take a look at that. All right, so that takes us to the question of testing. Okay, so as you know, which is what I had said we're going to talk about today as well, right? Leading up to the box model of testing. So input validation does not guarantee that subsequent operations on integers will not result in an overflow or in some kind of an error condition. Even though you might say, you know, in your e-commerce site, oh no, I have some pretty good JavaScript in there, and I have a few pretty good if statements in my functions, but input validation alone does not guarantee, okay? So testing does not, so the additional step is to perform testing. However, testing just provides more assurance, right, of your software, but it does not provide any guarantees either. So it just increases the probability that you'll find something, but it's not 100%, right? So it doesn't provide guarantees either. It is because, first of all, it is impossible to cover all ranges of possible inputs, okay, on anything but the most trivial program. So as you know, for instance, you're doing this e-commerce site, and my suggestion would be to do as much testing as possible, especially, you know, do as much coverage as possible, even though you can't cover every single text box. But make sure that, you know, if you're in a form and you have 5 text boxes, we'll try at least 2 or 3 and then try another page, you know, so you need to distribute out the way that you do the testing, because whether intentionally or unintentionally, I may have left some errors in there that you need to find, okay? And they could be as simple as just a out of range check. So you need to take a look at that, okay? What happens, for instance, when you type 0 on the cart and you update? Or what if you type negative? You know, does it subtract? You really need to check all of that, okay? And the only way to do that, because you can't anticipate every single input validation, is also to do testing. And that's what we're going to talk about in a few minutes. But if applied correctly, testing can increase confidence. And that's about all that you can do, that the code is secure. You know for a fact you guys have grown up with Windows, and you know that Windows, I mean, you know, Windows invented the model of let's send the code when it's 80% there, and then let's just patch it, right? So that's why Windows is constantly updating. And so Windows is constantly updating, and that's really the idea. They're updating the software. But, you know, the life cycle of a program does require testing, and that's why this class requires that as well, right? Requires that not only, remember, I haven't given you code to write from scratch. Instead, you got code for code auditing, but also for input validation and testing, okay? So now I want you to know that I've officially assigned this part of the project to you. I would argue that you should spend, of all the time that you spend on the project, you should spend between 60 and 70% of your time on coding. And you should spend, and look at this number, between 40 and 30% of your time on just testing it, okay? So that's why, don't think that when you finish the checkout that you're done. That's great, but you still got to do a lot of testing. And this is only the amount of time that you spend on it. So quite a bit of it should be spent on the testing of it. So, you know, there's a lot of types of testing that we can do, not just for numbers, obviously. I mean, some inputs can be like the address, you know, and so on, okay? So there's a lot of things. But integer vulnerability tests should include boundary conditions for all integer values. If type range checks are inserted in the code, test that they function correctly for upper, lower bounds. If the boundary tests have not been included, test for minimum and maximum integer values for the various integer sizes that you will enter. Notice here it says use white box testing. So we will define this in a while, in a few minutes. And that's just part of the box model of testing. Okay, so you will use that technique, which is really simple, to determine the types of integer variables that you need to worry about. And then, of course, if the source code is not used, then you run the test on the various maximum and on the various inputs, basically. That's what that's saying. And that's called the black box testing. So we'll talk about both of those in a sec. Source code audit. Again, you know, I've mentioned this term several times. You are auditing the code, right? So this code doesn't really require to write much from scratch. The only things you have to write from scratch are the login and your own module, where you write and read from the database. But otherwise, most of the code is just there, and the fixes are just little errors that you just have to find as you debug it. So you need to audit the code. You can see that source code, which you have a lot of. Remember, it's written in MVC style, should be audited or inspected for possible errors, including, in this case, integer range errors. When auditing, check the following. Integer type ranges are properly checked. Input values are restricted to a valid range based on their intended use. Integers do not require negative values. That do not require negative values are declared as unsigned, and this basically applies to C, C++. Okay, so basically just use the appropriate data type for your numbers. Okay. So let's take a few minutes. Let's take a look at this problem, and let's try to identify what's wrong with this one. This is a C, C++, obviously. So what do you think? Obviously, it's an integer security, but what might be the issue here with this one? Who can tell me? What's the problem here? All right, so let's look it over. You have some inputs, right, from the terminal. You got a variable. Oh, this is an unsigned short int total. Then you have that is initialized to a variable that is going to be the string length of the two inputs that you might receive, argv1 and argv2, plus 1. So whatever the size is of argv1 and argv2 plus 1, that's going to be the size of total, and then that total is used to allocate in the heap, right, and you dynamically allocate in the heap space and memory of type char, right? You can see that there, and that's going to be your buff. So then you've allocated the space and memory, and now that you've allocated the space, you take the value of argv1 and you string copy to buff, and then the rest is a concatenation of whatever is in argv to buff, right? So you just add it in there. So what might be the problem with this one? It looks right, don't you think? It looks like it's correct. So what could be the issue? All right, so let's take a look. right? So you can see it accepts 2 string arguments and calculates their combined length plus an extra byte for the terminating null character. Memory is allocated to store both strings, okay? Now, keep in mind, one important issue is the unsigned short int total. Remember, that means that total is limited in the size, right? It's going to be limited to that size. So the first argument is copied into the buffer, and the second argument is concatenated to the end of the first argument. So the vulnerability is an attacker can supply arguments such that the sum of the lengths of the strings cannot be represented by the unsigned short int total. So that is to say, unsigned in total, it's unsigned, right? So it goes to some value, but then when you calculate dynamically the lengths, it could fall outside, okay? And if it falls outside, then, something like that, and that creates a problem because, you're not going to be able to allocate the correct amount of space. So an attacker can supply arguments such that the sum of the lengths of the strings cannot be represented by the unsigned short int total. The string length function returns a result of type size t, an unsigned long int. As a result, the sum of the lengths plus 1 is an unsigned long int. This value must be truncated to assign it to an unsigned short int. And so it's just not going to fit. If the value is truncated, obviously there you have a problem. Now, you've allocated something smaller. So malloc allocates insufficient memory. And then notice the functions that we were using, right? String copy, string cat. What did we learn about those functions? Were they good functions to use? Would you recommend them?
Buffer cannot check the length.
Because no, right? Because they don't check length. So they were actually the function that we always use in the buffer overflow lab, if you remember, right? So there's the problem. So if the value is truncated, malloc allocates insufficient memory, and string copy and string cat will overflow the dynamically allocated memory. And you can see that at this point, your alarm bells should be going off, right? Because you're thinking, that's, I don't like that because I know what can happen with overflows. Even though this is another section in memory, you still would not like this because it could lead to a serious vulnerability. Okay? Are there any questions so far, guys?
Nope.
All right, so it sounds like everything's making sense. Good. Okay, so now that basically by talking about integer security, I get to cover a lot of topics actually in an efficient way. So we're done with that now. You can read through the summaries. Basically, it's just what I just said. And now we are ready just to move to testing. The idea of software testing, because this is something, as I said, should be between 30 and 40% of the time spent on your term project. Okay, so you're going to be doing this idea of testing. And at the end, I will show you a template. So remind me if I forget that I have a template on Brightspace of how I want you to proceed with the testing, how I want you to sort of document it. Remember that you're creating, as well as having the code and everything that you're doing with the code, you're also creating the documentation for the project. And the appendix A, let's say, of that documentation should be the testing documentation, right? Which will have the templates in there that you're doing, okay? All right, so that's what we're going to talk about now, which is the testing. And, you know, it's nothing difficult either. It's just, you know, more of the same. Pretty simple. Okay, so software testing is an investigation conducted to provide stakeholders. Stakeholders would be you, your company, the owner, whoever paid you, if you're a consultant, all of that. So software testing is an investigation conducted to provide stakeholders with information about the quality of the product or service under test, right? So you want to say something about quality. It's about quality control and so reliability, basically. So software testing can also provide an objective, independent view of the software to allow the business to appreciate and understand the risks of the software implementation. So test techniques, the process of executing a program or application with the intent of finding software bugs, errors, or other defects. That's the definition of testing, right? So it's really, you do it when you program, right? So you already do it, you know, whenever you code, you run a little bit and then you see what happens and you debug and all of that. That's basically part of this, okay? It's just that you want to more officially say, oh, you know what, I'm doing the software testing, so that it's documented that you have done it, that you have spent some time on this process on top of the coding. And in particular, sometimes it's good for this to be done by an independent person or an independent team, if you will. Okay. So here in the software testing, testing can be stated as the process of validating and verifying that a software program or application or product, you know, meets some conditions. So in this particular case, it meets the requirements that guided its design and development. So technically, this is why you have in this course, in the project, you have, you know, the e-commerce site itself, e-commerce code, let's call it, but you also have the documentation, right? So you have the documentation, which is, you know, they go together. So really, this is the specification that defines the code. This is almost like an agreed upon contract, right? So when you do the software testing, it's the process of validating and verifying that a software program meets the requirements that guided its design and development. So it meets that definition, okay? It also that it works as expected, right? So that it actually does what it's supposed to do, that it can be implemented with the same characteristics, and that it satisfies the needs of the stakeholders. So it's a verification, basically, of that it's meeting its goal, in short. Software testing, depending on the testing method employed, can be implemented at any time in the development process. So it doesn't necessarily need to be something that happens at the end, like when you're done, or like when Microsoft is about to release a program. Okay, we need to test it before, you know. It can be ongoing as part of the life cycle, okay? And traditionally, they have life cycles now where they do that. They kind of integrate the testing at all times. Traditionally, most of the test effort occurs after the requirements have been defined, right? So you obviously want to define the requirements, document it, and then the coding process has been completed, but it doesn't have to be that. It should actually be more ongoing as possible. You know, finding, I think we saw this at the very beginning of the semester, finding an error early is a lot cheaper than finding an error much later, right? Although even though nowadays you do the updates and everything, still it can be costly, right, to do those updates, etc. So a good example of this is cars. In the car industry, they can't just update the software and fix a car. They have to do recalls, right? So imagine if the software industry was the same. That, you know, would be very, very expensive. So software models, different software development models will focus the test effort at different points in the development process. Newer development models such as Agile, etc., you know, whatever, often employ test-driven development and place an increased portion of testing in the hands of the developer before it reaches a formal team of testers. So here the takeaway is, you know, that the developer does some testing and then you have a team of testers as well. So that's what I want you guys to do in the project. Is I want you, even though sometimes you're debugging and fixing things, go ahead and document things in your testing templates so that it just, you know, I'm really just looking for evidence that you went through the process, okay? If you find an error and you fix it, then, you know, it's fixed, it's no longer there. If you didn't do enough testing though, what might happen is when you do your presentations at the end of the semester, I might encounter some of the errors as we're debugging the program, and that will just show that you didn't do that much of the testing. So that's not, you know, that wouldn't be the goal. In a more traditional model, most of the test execution occurs after the requirements have been defined, and, you know, this has been said already. Okay. So testing can never be completely identified, can never completely identify all defects, right? So that's not feasible. You know, humans make mistakes, whether syntax or logic, you know, or just you never thought of something, right? And so it's going to be very hard to make it perfect. Instead, testing furnishes a criticism or comparison that compares the state and behavior of the product against principles or mechanisms by which someone might recognize a problem. So basically it compares the state of where you are versus where you want to be, right? So it compares to specifications. It'll compare to contracts, right? Because you're going to get paid if you meet the goals of the contract. Compare to comparable products, past versions of the same product, right? You might say, oh, this, you know, Windows 8 is not as great as Windows 7 or something like that. Inferences about intended or expected purpose, the expectations of the customer as the users start to use it basically, and they start, you know, testing the usability of it, etc. Relevant standards that might be out there, and even applicable laws, right? So laws can govern how software gets written, right? Okay. A primary purpose of testing is to detect software failures so that defects may be discovered and corrected, so that's pretty obvious. Testing cannot establish that a product functions properly under all conditions. Okay, that's impossible. You can only establish that it does not function properly under specific conditions. So basically, if you have run a test and you find a unexpected behavior, okay, you've met one of those conditions. The scope of software testing often includes examination of code, so the actual code itself, but also the execution of the code. So while the program is running, seeing how it behaves, how it takes inputs, and so on. And then, you know, so you want to see if it meets its goals. In the current culture of software developing, a testing organization may be separate from the development team. So you might have the testing group and the development team. You know, or it can be kind of mixed in. You know, it doesn't matter as long as I said, for our purposes this semester, I really just want you to go through the process, document it, you know, and that should be enough. And of course, as you might imagine, any information derived from software testing may be used to correct the process by which the software is developed. Every software has a target audience. So for example, the audience for video game software is completely different from banking software, right? When an organization develops or otherwise invests in a software product, it can assess whether the software product will be acceptable to its end users. And, you know, video games don't need to be super secure versus banks need to be secure. At the same time, you want a video game to be really fast or appealing, etc. So different objectives there. And what this means basically is that every project is going to be different, and you just kind of have to figure out what your goals are going to be for the testing itself. So a very fundamental problem with software testing, and this is actually a problem you will have in your project, is that testing under all combinations of inputs and predictions is not feasible, even with a simple product. This means that the number of defects in a software product can be very large, and defects that occur infrequently are difficult to find in testing. In your project, there may just be one little error or something, and it might be very well hidden. All right, but you know, finding it is going to be challenging, and so that's what you have to think about. What are some strategies to find these? And then there's other issues to think about, like usability, scalability, performance, compatibility, reliability. We're not really so worried about that because we're not thinking about, you know, performance or compatibility. Just for our purposes, just make sure it does, you know, don't get errors. Okay. So here, this is, you know, some people might argue that you have to establish a very scientific plan of testing. I would just say, for your purposes, use a very your own good judgment, because it is a reality that you can't test everything. So you're going to try to use some type of combinatorial test design to identify the minimum number of tests needed to get the coverage you want. So this is the example of like in a factory, right? In a factory, you produce widgets, you produce some kind of product, and you're not going to test the quality of every single product. Instead, on a random basis, you're going to pull from the assembly line a product here and there. And then after a while, if you don't see any errors, you're going to basically say something about the rest of the products in the production line. And that's similar here. You know, you don't have to test everything, but because you're doing it randomly, in, you know, combinatory, you know, a combination of things, you can start to trust your software a little bit more. So the goal is to have greater test coverage with fewer tests. Okay, so, you know, certainly, as I said, randomly pick a few text boxes from every form or from a few of the most important forms. But don't just say, oh, I'm just going to pick the forms that will be, the, you know, like the checkout process, and that's it. You got to cover a little bit more of it. Okay. Okay, so testing can be divided into static versus dynamic testing, for instance. So there are many approaches to software testing. Static just means reviews, a code walkthrough, and they're referred to as static testing. Dynamic is actually executing the program code. So you're actually executing the code with a given set of test cases, and that's going to be dynamic testing. That's pretty easy. So one is reading the code, one is running the code. You know, so read it, run it. Okay, and that's pretty much it. Sometimes you will omit the static testing and you just focus on dynamic testing, which is basically running the code, as you might know, right? So you run it, you run the software, and you just see what the input and the output of a function is, or you run the entire program, you enter inputs, and you see what happens. Okay. All right, the box approach. So as I said, the box approach just means performing what is divided into, you know, software testing methods are traditionally divided into white box testing and black box testing. The two approaches are used to describe the point of view that a test engineer, you know, the tester, takes when designing test cases. Okay, so that's really all that means. Who is doing the testing? From what point of view? Is it the user or the developer? Ultimately, that's really what it comes down to. So in white box testing, you know, this is going to be like the developer, right? So it's going to be somebody that writes the code, that reads the code, that can understands the code as written, knows about programming, you know, and software development. So white box testing, also known as clear box testing or glass box testing, transparent, etc. So here it tests the internal structures, okay? So it's gonna test the actual source code or workings of a program as opposed to the functionality exposed to the end user. So here you're gonna check, you know, functions, you're gonna check, you know, okay, this block of code from here to here, from line 20 to line 40, how does it flow? You know, what's going on? In white box testing, an internal perspective of the system as well as programming skills are used to design test cases. So this is usually the developer. So that means, you know, whenever you've written code, whenever you were doing debugging, you actually were doing this type of white box testing. The tester chooses inputs to exercise paths through the code and determine the appropriate outputs. This would be analogous if you wanted to think about like circuits, you know, running electricity and seeing how it flows, or the pipes in a house, etc. Okay, so basically this slide, you know, I'm not gonna go into that much depth. You know, just what I will say is just pick a few parts of your code, functions, etc., and run, you know, run an input through a few lines of code and see if you get the behavior that you were expecting. Okay, so again, the idea is to kind of look at the code and make sure everything is correct. And remember, we talked about coverage, so you don't have to test every single thing. But just try to create a smart approach of how you would do that where you think it would give you the most confidence. Black box testing, on the other hand, this is the end user. Right, so this, you know, so here you don't see the inner workings of the code. So you treat it basically as a black box. Okay, so you know that expression, so you treat something as a black box, it basically means, okay, I don't know how it works, but I know there's inputs and outputs. So the black box testing treats the software as a black box, examining functionality without any knowledge of internal implementation. The tester is only aware of what the software is supposed to do, not how it does it. So, you know, your grandma, if your grandma's not great at computers, right, then, you know, but she knows how to enter information in a program, you know, how to use some specific program. So that's basically the difference. between white box testing and black box testing. So the developer, everything is done from the point of view of the developer, or everything is done from the point of view of the end user. Okay. So it tests the functionality of the software according to the applicable requirements. This level of testing usually requires thorough test cases to be provided to the tester, who can then simply verify that for a given input, the output value or behavior is either is or is not the same as the expected value specified in the test case. So based on this definition, I have put together a template that I want you to use, okay? So test cases are built around specifications and requirements, which is what the application is supposed to do. It uses external descriptions of the software, including specifications, requirements, and designs to derive the test cases. All right, and that's it as far as the slides is concerned for today. So now I'm just going to go ahead and move to the bright space, because I want to show you the what I'm talking about when I say the template. So let me share. Let me share the screen here. All right. Okay, so if I go here, and I think I need to go to project files. And in project files, as you know, there should be a template in here. I think it's probably this one. Yeah, that's the one. So as you can see, this is what I call the testing template. As you can see, it's very simple. You can see here, this is what I'm looking for as far as the appendix A for the documentation of your project. You are simply going to create something like this, right? And then you're gonna perform the testing. So as you can see, it's just a little template. It indicates, testing the checkout page, or, function testing of forms function, inc.php. So all the different files, right, or places in the code that the cart, so cart there. All right, and it just has a specific set of fields. So you have you give it an ID, some kind of a number so you can reference it. Then you specify, so these are, for instance, fields. So they're text boxes, basically. So you're gonna say something like, okay, the field is quantity, and then these are the test cases. So the input will be to type negative numbers, letters, @ signs, single quotes, etc., right, for SQL injection. And then you're going to take note of the things that you would expect. So you need to specify that the expected result was, to update the quantity, to set the value to 1, set the value to 1, set the value to 127, something like that. Whatever it is, or an error message. And then as the person is performing the testing here, they're going to actually note the result. So they're going to take in, okay, I expected update quantities and I got update quantities. I expected set a value to 1, I got a set value to 1. And then finally, then you just say pass or fail, right? And that way you keep that, even though you're going to fix it later, even though that's going to be fixed, don't change it from fail to pass, okay? Because the idea is that you're going to then use this template to kind of quantify the number of errors you got. So you can see here, fail, right? So they were supposed, in this, they were checkout page, first name, they ran this test, they were supposed to get an error message. Instead, it inserted a name. And so that means it failed. Obviously, you'll fix that, but the idea is that you've recorded it, and that way it gives you a sense of where everything is. Okay, and so you can grab a function too, so you can have a list of functions that you want to treat as black boxes, right? And then you know what the inputs are, a variable of some type, and then what is the expected value, what is the actual output, and does it pass or fail? Obviously, you take a look at this. It'll make more sense as you start reading through the code, but this is the idea. You can also check conditions, if statements, so it can be, so this can be used both for white testing and also for, or white box testing, sorry, and also for black box testing, okay? So both of them can be applied. So really, when you do the project, please just use this approach, this template. That should be enough to show me obviously this is not enough. This is just a sample. I'm not saying that, oh yeah, I just need to have a few pages, right? If you notice, this had like 20 pages, but I just scanned a few of these just to, kind of illustrate an example so that you know what you need to do. Do you guys understand what you need to do for testing now? Is this helpful?
Yeah.
Yeah, okay. So as I said, this document just needs to be one single document that's going to be the Appendix A. It's not part of the basic write-up of the document, but you can reference it from the document as, oh, see Appendix A where we find this, and then you can provide some statistics of your fail to pass rate. Maybe you did something like right now in early November, and then you run it again in late November. Hopefully the one in late November, which is your last one, because by then you'll have to percent almost, will be with fewer errors, right? Because you've addressed a lot of things. But as I said, you keep them documented. Even if you fix the error, keep it documented so that you just have a record of what you have done. Okay. Ultimately, my goal is just to get you guys to go through this process so that you're aware of it and the sort of the significance of it. Okay. All right. So are there any questions about the template at this time?
No, not at this time.
All right. Now, given that I'm here in the projects folder, I also wanted to highlight something that I haven't yet pointed out, and is that I also posted the questions for the project. Make sure you print this out, okay? Because this is a good guide of some of the things that you should address. So for instance, you can see here, let's look at the questions. So we have, question number 1, how did you secure the site's inventory and sales administration pages? So what do you think I mean by that? What's the problem now with inventory and sales administration? Anybody could find it, right? If you guys just type the URL, you'll get to those pages. And then somebody could modify your inventory, ship goods, etc. So you will need to secure that. So remember, when you create the login, you should have a login for employees, employee type users versus customers, okay? How did you handle database and user permissions? We talked about that on last week. How did you secure the database password information? You'll have to think about that. How did you protect your new module from SQL injection? These are the modules you're writing, like the SQL injection, the login and your own modules. So that's just basically the SQL injection lab. Kind of have to follow the same ideas. How did you protect your new module from cross-site scripting and other code injections? So that's next week's lab. So hopefully after that, that'll be clear. What would you recommend using chroot sandboxing in your site? Explain why or why not. So that's something I have to cover. What is chroot? But that's just sandboxing in Linux, right? So that's something, but we'll talk about that later. How does same origin policy affect your website? You should be able to answer that question now. How does the e-commerce website handle SQL injection? So you'll have to think about that one. Did you leave error messages enabled or disabled? Explain why. So you have to look at that. So currently, error messages, might be there to help you debug, but eventually you probably want to turn them off so that an attacker wouldn't get additional information about your site. What is the function of SSL on your website? You're configuring encryption, so you should be able to answer that. Does the site use certificates? Why or why not? You should be able to answer that. What configurations that you have to set up on the server VM to protect and enable your site? So this would be like patching, updates, etc., which you should know how to do that. Once on an HTTPS page, what did you change to in the code to return to an HTTP page? So in your case, I believe you guys said nowadays the standard approach is to make everything HTTPS, so you'll have to change for that. Did you have to change any parameters in the php.ini file? You'll have to explain. Clickjacking is something I'll talk about later. Did you use stored procedures on your website? So when you do your code audit, you should be able to answer that. What was the purpose of authorized.net? I've explained that already, so you should be able to answer. What are the major problems that you found when doing white box testing of functions? You'll need to answer that. What were the major problems that you found when you were doing white box testing of conditional structures, variable ranges, which we talked about today, major problems with black box testing, so you'll need to answer all those. How did you validate input fields such as the credit card numbers? You need to find that. How is that being done? Even if you know that it's already being done, how? What is the purpose of htaccess? That's something I actually need to talk about a little bit more. And in the future, how would you handle new versions of PHP and deprecated commands? You'll have to do a little bit of research on that. So these are not all the questions by any means. These are actually the least obvious questions, but there are other more obvious questions that are not here. Okay, just about getting the website to work and all of that. Okay, all right, so anyway, that's basically today's topic was, as I said, software testing, and in particular, looking at integer security as an example of testing, right, of the things that you have to look at. So we've covered both topics. There won't be a lab for integer security, but for software testing, you have a lot of work related to your term project for it. So please don't forget to do that, okay? So at this point, I really don't have anything else left for today as far as new material. Just keep in mind the same recommendations. Work on your term project. Keep track of the calendar because we're starting to run out of time. And on Thursday, we will pick up where we left off last week by, I'll go over the last part of the SQL injection lab, and then that will be your last day in the lab to work on SQL injection, given that next week we will start the new topic of JavaScript injections and cross-site scripting, which actually I think you will really like. It's a very interesting lab. We're going to do an internet worm. So like virus, computer virus, but it's going to be an internet worm, and you'll see how it propagates over a network and basically through like a Facebook type of a thing. So it's a very, very, very cool, I think, lab. So I think you'll like it a lot. But please also pay a lot of attention to the SQL injection lab. Very important, very, very good. And let me know on Thursday if you're having problems with it, because, as I said, you will need to complete it a week from Thursday. All right, so I'll stay for a couple of minutes. If you have any questions, I'm going to stop sharing at this time. And